Here's a list of things you may need to remember when trying to find the equation of a polynomial given its graph. The key terms to remember are degree, multiplicity, and roots. Mathematicians! Now we're going to talk about end behaviors. So our first one is an even degree positive leading coefficient. Even degree just means that it's going to look sort of like a quadratic function, and the positive leading coefficient just means it's going to open upwards. So this graph is also even degree, so same end behaviors, but this one has a negative leading coefficient, which means it'll just open downwards. Whoa, that's a crazy looking end behavior, but don't be fooled. Odd degree positive leading coefficient just means that it's sort of going to look like a linear function with the end behavior, and it's going to start, or it's going to go from quadrant 3 to quadrant 1. Boom. Alright, similar to the last graph, odd degree negative leading coefficient. The negative leading coefficient just means that you flip the opposite way.
Alright, what's good, what's good? So pretty much here you got your even degree with a positive leading coefficient with roots at -4, -2, and 3, and a y-intercept of -3. And as well, the root of -4 has a multiplicity of 2. Alright fam, let's get it. So pretty much, we're going to go back to review our end behaviors for our graph. So as x approaches infinity, you know f of x also approaches infinity. And as x approaches negative infinity, you know that f of x also approaches infinity. Alright, let's get it. So here we can see that for our roots, we got two -4s, a -2, and a 3. And here we can see where they're positioned on our graph on our x-axis. Alright, so pretty much what we're going to do now is turn these roots into factors. So here you got x plus 4, you're going to square it because the -4 has a multiplicity of 2, and you got x plus 2 and x minus 3.
Alright, this function shows our factors multiplied together, and this a here is our leading coefficient, which we will find next. Alright, now to get the leading coefficient, we're going to need the y-intercept, 0, -3. And this will be useful to us because we're going to need some algebra. We're going to substitute the 0 in for the x and -3 for the f of x or y. And this is what your function will look like. And after solving the algebraic equation, we will come up with a equaling 1/32. Now with the 1/32, we're going to place it where the a was, or the leading coefficient, and next we'll distribute it to all the terms. After distributing the 1/32, we come up with this, and this is our final function for this graph.
Alright guys, so here we got another example. We got an odd degree with a positive leading coefficient, as we can see on the graph, with roots at -2 and 3. And the root at 3, we can see because it's a touch and go, it has a multiplicity of 2. And we can also see the y-intercept of 2. Alright guys, so to review our roots for the graph, here we can see that we have -2, 3, and 3, because remember 3 is a multiplicity of 2. And here's a quick shot of our graph. Alright guys, so here's the y-intercept of at 0, 2. We're showing you this now because it's going to be important later on in this video when we're finding the equation of the polynomial. And here's a quick look on the graph where the y-intercept is. Alright guys, so here we can see we have our factors, which are going to play a big role later on when we're going to find the equation of the polynomial for our graph. So we can see that our factors are x plus 2 and x minus 3 squared, because remember it's touch and go and it has a multiplicity of 2. And here's both of them on our graph.
Now to get our polynomial, we're going to need to multiply these factors and use this a as the leading coefficient. And now we're going to find the leading coefficient. Alright, we have already multiplied all the factors together and found the leading coefficient, which has come out to 1/9. And if you don't remember how to find the leading coefficient, please refer to the example we did earlier in this video. There we went through the steps more clearly. So now that we have found our leading coefficient of 1/9, we're going to place it where the a was, and next we will distribute it to find our polynomial. After distributing the 1/9 to each term, we come up with this polynomial equation, and we could check the validity of it by substituting in the ordered pairs that we know, and if they come out correct, then we're all good to go. Alright, thanks for watching. We'll catch you from wherever we are next time. See you later.